Hey everyone, and welcome back to the channel. I've got some really exciting news from the world of AI, specifically about making powerful AI models work on the computers many of us already have. If you've been wanting to run cutting-edge AI like Google's Gemma models but thought you needed a super expensive setup, this is something I think you're going to want to hear. So, Google recently launched their latest and greatest open models called Gemma 3. Now, these models are seriously state-of-the-art, but initially, to run the biggest versions like the Gemma 327B, you'd typically need a high-end professional GPU, something like an NVIDIA H100. That's awesome for big companies and researchers, but maybe not so much for folks like me or many of you at home, right? When I talk about these large models, they often use something called bfloat 16 precision. I think of this as the standard, high-detail way the model's internal numbers are represented, using 16 bits of information for each number. This is great for performance but requires a lot of memory. In fact, comparisons of different models are often done using BF16 to have a fair, apples-to-apples look at their raw capabilities before any optimizations. Well, the fantastic news is that Google just announced new versions of Gemma 3 that are optimized with something called Quantization-Aware training, or QAT for short. Now, that might sound a bit technical, but the really cool part, from my perspective, is what it does. It dramatically shrinks down the memory these models need to run while still keeping their high quality. I like to think of quantization like compressing a high-resolution image by using fewer colors. You make the file size smaller, but you want to do it in a way that you don't lose the detail and quality. Instead of using 16 bits per number like BF16, these new QAT models use fewer bits, specifically 4 bits, int4. This is a 4x reduction in the data size just for the model's weights. The key here, as I understand it, is the quantization-aware training. Instead of just compressing the model after it's fully trained, which is called post-training quantization, or PTQ, and can sometimes hurt performance, they baked the compression process right into the training. They simulated these low-precision operations during training for about 5,000 steps, using the full-precision model's outputs as a guide. This helps the model learn how to work really well even with that reduced precision, preserving accuracy. And the results are pretty incredible. Compared to traditional post-training quantization, PTQ, this QAT approach reduces the typical performance hit by a significant amount. They saw a 54% reduction in perplexity drop when quantizing down to the popular Q4_0 format used in tools like llama.cpp. This means the model understands and generates text much better than a simply quantized version would. Let's look at the VRAM, that's the memory on your graphics card, needed to run these models. This is just for loading the model weights. Remember, you need a bit more for the conversation history, the KV cache. The big Gemma 327B model, which used to need about 54 GB of VRAM in BF16, now only needs about 14.1 GB with this new int4 QAT version. That's a massive drop. The Gemma 312B model goes from 24 GB down to about 6.6 GB. Even the smaller Gemma 3.4B and 1B models see huge reductions, needing only around 2.6 GB and a tiny 0.5 GB respectively. What does this mean, in practical terms? It means I can now run the largest Gemma 327B model locally on a consumer-grade GPU like an NVIDIA RTX 3090, which typically has 24 GB of VRAM. Even with the KV cache, it should fit comfortably. The 12B model can run efficiently on laptop GPUs with 8 GB of VRAM, like an RTX 4060 laptop GPU. And the smaller models are accessible even on systems with limited resources. They even joked about running on a good toaster, which I thought was a fun way to think about how accessible they're becoming. These models use the same core structure and tokenizer as the original Gemma 3 and importantly, they preserve the instruction tuning and chat capabilities, so I expect them to be just as good at following instructions and having conversations. Google is really committed to making powerful AI available to everyone, and I see these QAT models as a huge step in that direction. The weights and files are publicly released under the permissive Gemma license, supporting both research and commercial use without needing a login or API key for local deployment, which I think is fantastic. Plus, they've made it super easy to get started. These new QAT-optimized models are available on popular platforms like Hugging Face and Kaggle in formats like gguf, which is widely supported. And they work seamlessly with tools many of you might already be using or want to try, like llama. I can get these models running quickly with just a simple command. LM Studio, great for easily downloading and running them on a desktop with a friendly interface. MLX, if you're on Apple Silicon, MLX offers optimized inference. Gemma.cpp, a dedicated C++ implementation for highly efficient running, even on your CPU. llama.cpp, easy integration into existing workflows that use this popular tool. Beyond just text, these models also support dynamic tool use and can integrate with things like function calling and custom tools, even handling mixed modality tasks involving vision, text, and code, which opens up a lot of possibilities for building interesting applications. While Google provides these high-quality official quantization-aware trained models as a great baseline, the vibrant community, sometimes called the Gemmaverse, offers many alternatives, often using post-training quantization, PTQ. I've seen significant contributions from members like Bartowski, Unsloth, and GGML readily available on Hugging Face. Exploring these community options provides an even wider spectrum of size, speed, and quality trade-offs to fit specific needs. So, if you've been wanting to experiment with cutting-edge AI models locally, I think now is a fantastic time to jump in. These new Gemma 3 QAT models really lower the barrier to entry and bring state-of-the-art performance to more accessible hardware. I'll put links in the description to where you can find these models on Hugging Face and Kaggle, and the tools like llama and llama.cpp to run them. What are you excited to build with powerful AI running on your own hardware? Let me know what you're thinking in the comments below. If you found this helpful, please give it a thumbs up and subscribe for more AI news and tutorials. Thanks for watching, and I'll see you in the next video.